Hello and welcome to Technical Utkranti, and today we'll continue with second question on arrays. So let's get started. This is our syllabus which we had already discussed in the first part of the series. So let's move on, and this is the question. So the question is, given an integer n, generate the first n rows of the Pascal's triangle. Let's observe how Pascal's triangle is generated. For the first two rows, it is straightforward. Just for the first one, just one element, and for the second row, you have two elements, 1 comma 1. For n greater than 2, here is the logic: prefix and suffix with 1. Then from the previous row, take the sum of two elements at a time and keep appending in the middle of this prefix and suffix. So for example, for n equal to 3, I prefixed and suffixed with 1, and from the previous row I took two elements at a time, their sum, and put it over here. Now the second pair does not exist, so that's it. Now for n equal to 4, I prefix and suffix with 1. Then from the previous row, I start taking two elements at a time, and their sum is 3. Sum is 3. So here is the fourth row. For the fifth row, I prefix and suffix with 1. From the previous row, I take two elements at a time, and do their sum and start filling the middle portion of the this row. 3 plus 3 6, 3 plus 1 4. That's it. So this is the logic. Now let's look at the code. Fine. So this line corresponds to the logic that we just discussed. I minus 1 is the previous row. J minus 1 and J are the two consecutive elements of the row I minus 1. Now let's start from the top. CPT is the list of lists, the complete Pascal triangle. Now in the for loop, we will calculate the row which is temp list. For like each row we'll calculate, and at the end of the loop we'll append it to the complete Pascal triangle, right? Okay, so as soon as the loop starts, this I equal to 0 case is just the first case where we are just having uh, just one element. This is the first row. This is the case for just the first row. For the second row onwards, we'll be appending and prefixing and suffixing with 1, and this logic will formulate the middle part of the row. Okay, what this condition is, this j will run from 1 to I. This will ensure that the middle condition is only executing starting from I equal to 2, which means the third row onwards. Because even in the second row, if you see, we have just prefix and suffix. We don't have any middle logic over here. So the middle logic starts coming from the third row, which in the code would correspond to I equal to 2. So that's why this is 1 comma I. For I equal to 1, this condition will not be running. For I equal to 2, this condition will just run once, as we need that only. For I equal to 2, only one pair will be there. For I equal to 3, j will run for 1 and 2, and therefore there will be two pairs, this and this. Okay, right? I hope you are getting my point here, right? So that's how the middle portion will be calculated, and then that particular row will be appended to the main Pascal triangle matrix, and this will go on to give us the complete Pascal triangle. And let's see if it works. So I'll generate it for, let's say, 5 elements, 5 rows. Yeah. Now here is one catch over here. When I was doing it, solving it on the lead code, I was, for this particular solution, my time complexity was just 42% better from all these submissions. Then I observed that okay, there is a scope of one improvement. Basically, if you see these three lines of code, which is computing my first row, this has actually nothing to do with the loop, right? This is just a hard code calculation. It is not computing anything. I don't need to do it in the loop. So what I could do is I could add the first element into the Pascal triangle, and I can remove this. I can start my I from 1 only, and yeah. So let's see if our code is working fine. Yes, it is working fine. So with this improvement, my time complexity improved from 42% to unbelievably 88%, which is quite good because we have removed that unnecessary calculation. Uh, and yeah, we are only doing necessary calculation right now in the loop. Yeah, so that was the solution for the second question. And this is not the 73rd, sorry, this is not the 73rd question on the lead code. So yeah, sorry. I will add the link in the description so that you can try practicing the question on lead code platform. So the lesson learned in this particular question was, if a certain condition is fixed and is needlessly executing in the loop, put it outside the loop to improve time complexity. So thank you. That's it for today, and hope you liked the video. Hit like and subscribe. Thank you. Bye bye.